All right, so there are two ways that we can do this problem, and you're welcome to do it either way. The first way is to actually find our inverse function. So here's f of x. To find its inverse, you would switch the x and the y, and then you would solve for y in terms of x. Then you would need to take the derivative of it because we're looking for f inverse prime. So you'd need to take the derivative, and then you would need to plug 645 into that. That's perfectly fine if that's the way you want to do it. Unfortunately, sometimes working with the inverse functions can get quite complicated. For instance, in this, our inverse function is going to be the cube root function of something, and it actually can make for a complex derivative. It's also somewhat time-consuming to find the inverse function. So if we can use this formula, that can save us time. So there's actually two ways, and I'm going to show you how to use this formula to do that. So the first thing I want to do is to get this notation looking similar to what we're seeing here. So this asks us to find f inverse prime of 645. In this formula, that's the same as just g prime of 645. All right, g prime of 645. And so what we have then is that's just 1 over f prime of g of 645. All right. So f prime, we're going to need f prime, and f prime is just the derivative of this. So f prime of x is just 9x squared, isn't it? 9x squared is the derivative of that. Now, before we go any further, we want to think about what g of 645 means. And to do this, I want to remind you what the inverse function represents. So I'm going to show you a quick picture. So here I have a picture to remind you of what the inverse function represents. If we put a value into our function and we get a value out, so this is our original function, we put something in and we get something out. If we put that output back into the inverse function, we're going to get our original input, all right? So if we put an apple into our original function and we get a banana, then when we put the banana into the inverse function, we're going to get out an apple. So what does g of 645 represent? Okay, g is our inverse function, and the 645 is the banana. So that was the y value that we would get out. It was the y value that we would get out if we plugged in the initial x value. Okay, so our y value that we would get out, so negative 3 plus 3x cubed is 645. And we're trying to solve for what the apple is. Okay, so this is our original function, negative 3 plus 3x cubed equals 645, and we want to find out what the x value is. So I'm going to add 3 to both sides, and I get 3x cubed equals 648. I'm going to divide both sides by 3, and I get 216, and then I take the cubed root of that, and I get x equals 6. So this g of 645 is actually 6. So I'm going to go down here. So g prime of 645 is just 1 over f prime of 6. All right. And I recall that f prime of x is 9x squared. So I get 1 over 9 times 6 squared, which is 1 over 9 times 36, and I'll calculate that right now. And that is 1 over 324. So that's it. Again, to solve for what g of 645 represents, we just set this original function equal to 645, and then we solve for what x is. Hopefully this helps.